Now, as we have taken in the previous session about xy coordinate system and a circle, now a secant is a line or a ray which cuts the circle, passes through circle at 2 points. Now, that 2 points which make a length, say I have AB, which is formed when this is extended up to here. This distance is called the chord. Here AB is called the chord of the circle, and the whole of AB when extended is called secant of the circle. That's how we understand the difference between the line segment AB, which is the chord, and the ray AB given by arrows as the secant of the circle. The chord is the part of the secant. Is how we understand the difference between chord and secant of circle. Now suppose I have a circle with center and the diameter as AB, and the coordinates of A are x1, y1, and coordinates of B are x2, y2 in xy coordinate system. Then in this case, the equation of circle with diameter extremities, that is what with the endpoints given for the diameter, I can derive the equation of circle as x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals 0 is the equation of circle with extremities x1, y1 and x2, y2. Now let's see the next concept of finding the equation of circle which passes through 3 points without any conditions out there. The only condition is that a circle passing through 3 points, I want to find the equation just by utilizing the 3 points as given out there. So let's see how we can find the equation of circle using the 3 points given. So for example, I have a circle which passes through 3 points, say A, which is 1 comma 1, and B, which is 2 comma minus 1, and C, which is 3 comma 2. So if I have the circle which is passing through 3 points A, B and C, then let's see how we can find the equation of circle. Now we all know that the general equation of a circle is given by x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So using this general equation, now the first point A equals 1 comma 1 implies this must substitute or satisfy the given equation of circle, because A11 lies on the circle. That means this belongs to S, implies x squared plus y squared plus 2gx plus 2fy plus c equal to 0. That implies I get 2g plus 2f plus c equals 0. So using the point A which lies on the circle, it satisfies this. Therefore, I get the first equation given by this. Similarly, my point B belongs to S, implies I get this to be x squared, which is 2 squared plus y squared 2gx plus 2fy plus c equal to 0. Thus, on simplification gives 4g minus 2f plus c equals 4 plus 1, which is minus 5, as equation 2 is what we get for this. Now thirdly, the third point lying on S also gives me the third equation. So let's see how we get the third equation. C equals 3 comma 2 belongs to S, implies S equals x square plus y square plus 2gx plus 2fy plus c equals 0. Therefore, this on simplification gives 6g plus 4f plus c equals 9 plus 4, 13, which is minus 13. Therefore, I have three equations which I have to simplify using the elimination method or the substitution method. So therefore, continued from here, I have my three equations which are obtained from each of the points A, B and C. Now I need to solve these three equations to find the three unknowns G, F and C using the elimination method of simultaneous solving. So in this case, I first take equation 1 and 2, which gives 2g plus 2f plus c equals minus 2 and 4g minus 2f plus c equals minus 5. Then I subtract the two equations, which gives me both f get cancelled, and I get this to be minus 2g, or not this, this gets cancelled, and I get this to be 4f equals 5 minus 2, which is 3, is what I get as equation 4. And this is obtained by doing 1 minus 2. Similarly, I'll take equation 2 and 3 and I subtract. So equation 2 minus 3 would give me, on subtraction, 4g minus 2f plus c equals minus 5, and my equation 3, which is 6g plus 4f plus c equals minus 3, on subtraction gives minus 2g minus 6f equals minus 2, is what we get for equation 5. Now I just consider equation 4 and 5 and I try to eliminate either G or F. So let's see how that is possible. Now let's consider equation 4 and equation 5, which needs to be further simplified. So now that in the previous session I have obtained equation 4 and 5 from these three equations 1, 2 and 3, I got my equation 4, which is minus 2g plus 4f equals 3, and minus 2g minus 6f equals minus 2. So let's eliminate g because their coefficients are equal. So it is always right that I eliminate that unknown whose coefficients are same, or we make the coefficients same to eliminate one of the unknowns. This is how we understand the elimination method. So therefore here, when I subtract 4 minus 5, I get plus, 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 and this gets cancelled, and I get 6f plus 4f, which is 10f, that is equal to 3 plus 2, which is 5. Therefore, my f is 5 over 10, that is 1 over 2. So f is 1 over 2, which on substitution gives me g. Therefore, f equal to 1 by 2 implies minus 2g plus 4f equal 3 is what I get from equation 4. from equation 4. I substitute f equal to 4. Therefore, this on reducing gives me minus 2g, 2 1s, 2 2s plus 2 equals 3. That is minus 2g is 3 minus 2, which is 1. That implies g is minus 1 over 2 and f is 1 over 2. And then substituting these two in one of the equations gives me c. So let's see how we can find even the third unknown c using the elimination method. So therefore, with the equations where I obtained f is half and g is minus half, I use these two unknowns and I substitute in equation 1. I get 2g, which is 2 times minus half, plus 2f, which is 2 times of 1 by 2, plus c equals negative 2. 2g plus 2f plus c equals 2. This on further simplification gives minus 1 plus 1 plus c equals minus 2, which on simplification gives c equals minus 2. Therefore, f is half, g is minus half, and c is minus 2, through which I am going to find the equation of the required circle passing through the 3 points A, B, and C. Therefore, the 3 unknowns are found to be g equals minus half, f equals half, and c equals minus 2, which I am going to substitute in x squared plus y squared plus 2gx plus 2fy plus c equal to 0, which on substitution gives me x squared plus y squared plus 2gx plus 2fy plus c equals 0, which on further simplification through LCM gives me 2x squared plus 2y squared minus x plus y minus 4 equals 0 is the equation of a circle which passes through the 3 points (1, 1), 2, minus 1, and 3, 2. Is how we can find the equation of the circle which is passing through 3 distinct points on the circle, and hence its equation in general form. Next is parametric equations of a circle. So what do we mean by parametric equations? Representing in the form of angle and radius is what is the parametric equation. So let's see how a circle can be represented in the parametric form. Initially, to start with, let's take a circle whose center is HK and whose radius is R. And let me say this makes an angle theta out here. The angle is theta. Now with this, with an angle theta made in the clockwise anti-clockwise direction of the radius from a suitable point P, then in this case we know that since the center is HK and the radius is R, we have the equation of circle given by x minus h whole square plus y minus k whole square equals R square. Is the equation of circle N with center HK and radius R. Now the parametric equations for this circle are said to be when I take my x minus h is r cos theta and my y minus k is r sin theta, because when I substitute these two, I reduce to the identity cos square theta plus sin square theta, which is 1, and I get the left hand side identically equal to the right hand side. So with this, I have the parametric equations where one is x equals h plus r cos theta and y as k plus r sin theta, which are called the parametric equations of the circle with center hk and radius r. The parametric equations connected with equation of circle involves radius and angle, the angle theta out here. Also, it is important to note that theta lies between 0 and 2 pi, one full rotation of the circle being 360 degrees, so theta lies between 0 and 2 pi. So for example, I have a circle whose center is origin and radius is r. Then in this case, I have the parametric equations given as x equals r cos theta and y equals r sin theta. Is how we understand the parametric equations, because h and k are zeros. When I substitute, the formula reduces to x equals r cos theta and y equals r sin theta, with 0 less than or equal to theta less than or equal to 2 pi. Similarly, if I have a circle with center origin and radius is 1, where this is called unit circle, then in this case I have x equals cos theta and y equals sin theta, because r is equal to 1, reduces to x cos theta and y sin theta, with 0 less than or equal to theta less than or equal to 2 pi. So the different cases have the different parametric equations of the circle connecting with radius and the angle theta. Now let's take one example problem to understand the parametric equations of a circle more better. To start with the problem, if my question says find the parametric equations of the circle x squared plus y squared plus 6x plus 8y minus 96 equal to 0, then let's see how we can find the parametric equations of this circle using the concepts learnt in the previous session. Now, as I clearly have the circle given by x squared plus y squared plus 6x plus 8y minus 96 equal to 0, then my center C is clearly given by minus g minus f, where my g is 3, f is 4, and my c is negative 96 from the circle. Therefore, center being minus g minus f gives me minus 3 minus 4 as the center, and my radius r is given by root of g squared plus f squared minus c, which gives me root of g squared plus f squared minus c. This gives me root 121, which is 11. This is how we obtain the center and radius. Therefore, my center is minus 3 minus 4 and my radius is 11. Now center, when I compare with h and k, my h is minus 3 and my k is minus 4. Therefore, the parametric equations are given by of circle are given by x equals h plus r cos theta and y equals k plus r sin theta, where I substitute h, k and r and then I get the parametric equations. So therefore, let's see how we get with x equals h minus 3 plus 11 cos theta and y is k plus 11 sin theta are the parametric equations for the circle with 0 less than or equal theta less than or equal 2 pi is what we get here.